I'm recording, so that's good. Okay, so this last chapter that we're going to cover is on strings. So, as I said in the video that I put out yesterday, not everything we're going to cover. Okay, so I thought I would open with a few comments about strings just to kind of tie everything together. And the book doesn't make a big deal of it, but strings in most languages are what we call immutable, which means they can't be changed. Okay, so um, it talks about the string builder class, which you don't have to care about at all. But the string builder allows you to build mutable character arrays. Okay. Mutable means changeable. So you can change part of one. Okay. So with strings, if you have a string S is equal to Bob, you can't change bits of that. You have to change the whole thing at once. You can create a new string and give it that variable, but you can't make changes with it. So that's the whole mutable and mutable. And that's why the string builder is a thing. Okay, but it's not something that I particularly cared too much about. Okay. I think the more important thing from this chapter, it's what both homework problems about, is the whole idea of a string tokenizer. We often in the world get data in a big string of stuff. If you have student records or whatever, you'll have first name, last name, and it may be comma delimited, it could be space delimited, it could be coming from an Excel file or whatever. We often want to break that into pieces, and that's that whole tokenizing thing. Okay, and that's the real takeaway of this chapter. I didn't want to dump a bunch on us at the end because I think for most of us, we're programming at a fairly decent level of Java. I mean, we're able to get most of the basic program stuff done. Okay, um, and this is getting us into a little bit of advanced territory, or not really advanced, just more pickier kinds of things, but they can be very useful. The first job I was dealing with these giant records that came on tape back in the day, um, and all I was doing was trying to extract data from them, and it was horrible. I had no tools at all. I had to write my own little code to do it. To have something like a string tokenizer would have they could have fired me and just had an intern do it. It's so easy now to do that. So I've seen firsthand the power of that string tokenizing. So it really is a pretty awesome thing. Um, and again, the other thing that I think that's weird in this chapter that's worth talking about, it's the idea of the primitive class data classes versus just the regular stuff. So in general, in Java, everything's an object. Okay, everything except the primitive data types, which we use all the time. Ints are not objects. Um, Floats and doubles and all those things. None of those are objects. Chars are not objects. Okay, they're the one exception. And the reason being, if you didn't do that, if you wanted to do 1 plus 1, you'd have to say 1.add 1, and that just it's cumbersome, so people don't do it. Okay, but strings are objects, so strings have a length, integers don't have a length. Okay, so that's the big difference there. But it talks about the wrapper classes. That there's an integer class with a capital I that is the wrapper class for the int. So int is a primitive data type. You can't really do much with it. But the integer with capital I, that is a class that has functions. Okay. And you can convert things back and forth between them. Okay. Again, I'm not going to test you on that, but when you're thinking about Java, that's one of the big things. Okay. The string builder is a big thing. The string tokenization is a big thing. I mean, Python has string tokenization as well, it just works differently. But what Python doesn't have is this idea of everything's a class. That's a Java specific thing. Okay. So yeah, I think the homework seemed pretty straightforward to me. I mean, it's a little fiddly, but my two problems are like 20 lines each. Seems like there wasn't much there. Okay. So if you have any questions about that, or questions about strings, or questions about the exam, or questions about anything, the floor is yours. Not the floor, the ether is yours.
I have a question about the telephone number
Yes.
one, and how should it be printed? So
Yeah, that's I don't know.
when,
None of the problem said in great detail. I didn't find it seemed pretty vague. So yeah.
yeah, I tried it a few different ways, and um, I mean, the way I have it right now is it prints like the area code, and then the first part of the telephone number and the second part of the telephone number.
Right.
And so like three in a row.
Right.
But do we need it to like label each of those? Do we need to have it? I mean, one of the things said the 7-digit phone number should be concatenated into one string. And like one way that I had printed it, so I didn't use the concatenation function
No, you don't need
like that it talked about,
Yeah.
but one thing I did was just took out the space and the hyphen, just printed it all in a line, but it had the area code with it.
Yeah, that was really weird to me because it starts off as a string. Why do they want to put it back into a string? So really, to me, what that program needs to do is to separate out the area code and I called it the exchange, and the number is what I labeled it. But those three parts need to be pulled out separately. And then
But do we need to label those three parts, or we can just print them one after the other?
In your code, the variable names will be for those three parts. Whatever you choose to call them.
Oh, I didn't do it that way.
So
I didn't do it that way either.
So when you token, because if not, I mean, there may be other ways to do it, and I'm not going to be super picky at this point in the semester, surely. But when you do the split, it's going to return that array of strings, and you have to do two splits, right? Because there are two different delimiters you're working with. So you've got a space delimiter for the first one, you've got a dash for the second one. Okay. So
because I did it in one, and it took me forever to get it to work. Can I share it with you and show you?
Yes, sure.
Okay.
I think the book had an example of that because eventually I figured it out too. But I thought we had to ask. I know it gave us the phone number.
Right.
While you're sharing that, I'll just ask my question and sometimes I put too much thought in things. But it said let's see. Write an application that inputs a telephone number. So does that mean we have to ask somebody to input? Like the user would be inputting a telephone number?
Yeah, I didn't do that, but yeah, and I'm not going to complain if you didn't, but yeah. That's what it wants.
Okay, because I didn't.
Well, I couldn't get it. Did you do
No,
that, Tara?
I was going to ask about that too, because I didn't. I just had one already, as its own.
Me too.
But then that's why I asked Dr. Frazier, I couldn't get it to reverse. I couldn't get it to catenate because in doing that, I can share mine after Christina, but I didn't separate it out into strings. It was getting a little confusing.
You guys did the regular expression, which is the other way to do it.
Okay, so, and that's what it took me forever to figure out how to get it.
Yeah. See, that's the difference between a new programmer and an old programmer.
Okay, I didn't do it that way, but I also did it where it would take out both.
What does that mean? A new programmer and an old programmer?
Let me show you my code. Unshare yours, Christina. I'll show you mine.
Okay. But is that correct?
It's fine. Yeah, if it works, it works. But it required much more thought. What I did was just...
It took me a little while.
See, I just split it the first time. And then I set the area code equal to the first of those. Then I left the telephone
indexing
to that.
Yeah.
And then I did it again. Boom, it's done.
I wish I could think of that stuff.
That's experience.
Hey,
lots and lots of experience.
David,
okay, so that way you were able to label them.
Yes.
Like you gave them a name.
Yes.
Oh, okay.
Okay. On mine, when I went back to go print it, because I did print it as a 7-digit.
Right.
But I used the array, like the array indexing, and did like token 0 plus, it was like token 0 was 1, and then I think like token 2 and 3 or 3 and 4, something like that. Just concatenated those together.
That's fine.
Okay.
That's okay. Yeah, it's not a big deal. In fact, mine just prints out. It said to concatenate them together, so I just did that, which looks ugly, but I couldn't tell what it meant. It was weird to me what they were saying, but it doesn't have to look like this at all. And
I'm sorry.
No, go ahead.
Wasn't the second one sort of like it?
Similar. You do a split.
But you said we needed a for statement. I never could get my for statement to work.
Well, I can show you the second one here.
Well, so
And could
Kind
you
of
go
like-
over a for statement, like just everything?
Okay, so what we're doing on this one, okay, so in this case, we're having the user enter a sentence without punctuations, right? So then I'm doing this input.next line to pull that out of there, okay? And this other print line is just to make it so it looked a little better on the printout. So s is equal to whatever they type in, okay? And then I'm doing the split into a array of words, splitting on the space, okay? A better way to do this may have been to convert to all lowercase, because if there's an uppercase letter, then it's going to get all messed around, and I'm not dealing with, I say without punctuation, but I could have made this better, certainly, okay? So once I did that, I first just did this. Was testing to see if the words were in the correct order when I pull them out. So I did the little shortcut for the string st is going to get one by one all of the elements of words. Okay, so we can take the comments back off of that one. Okay, and that's going to print. And for me, just so I would know what I was doing, I would do 1, 2, 3, 4, 5, just because it's easier. Okay, so the first thing it does, this loop then with this for structure, which is that weird one I don't really like much, but it works okay here. It's going to print those out in that order. That's all that does. Okay. So once I did that, to reverse those, and let me read the question again, because it may want me to do stuff I didn't do. It wants us to display it. And outputs the token reverse order. So you don't have to do anything physical, because you could rearrange your array, but you didn't. Okay, so I have words right now. It's going to be, in my case, 1, 2, 3, 4, 5. Okay, so the indexes are going to go from 0 up to the length minus 1. Okay, so I've got 5 words. 0 to 4 are the legit values. Okay, so to go through in reverse, I want to count down from the 4, which is equal to the length minus 1, down to 0, decrementing each time. Okay, so that's what this loop does. So the 4, when it's not this weird version of the 4, this version of the 4 has 3 parts. It's the initialization step, okay? It's the when are we done step, or the termination step, and then it's what do you do to go to the next line, okay? So in this case, I'm using my int c like I always do. I'm starting off with words, which is my array of words I entered in, dot length, which will be 5 in my case, minus 1 is 4. So the first time through, c is equal to 4, okay? I'm going to continue along as long as c is greater than or equal to 0. When it gets to -1, I've gone too far. So it's going to go 4, and then this c minus minus says it's going to go 4, then 3, then 2, then 1, then 0, okay? So then I just print out those words all in one line, and we're good, okay? In fact, if you wanted, I could print out that. I can't do that. It's going to be ugly. I can't do that well, but what you could have done before you did that, if I would have done a print line here, I could do that. So if I do that, it's going to show. It goes the 4, 3, 2, 1, 0. Okay, which is what we want. Okay. So there may be other ways to do that, but that seemed the most straightforward way. Okay.
And you said the for statement was to initialize, to show where it ends and where it's going next, correct?
Yes. The initialization,
Okay.
the termination, and then the continuance.
Thank you.
Okay. So again, the initialization means the very first time c is equal to length minus 1. So it's 4. Okay. So we check, is 4 greater than or equal to 0? Yes, so we keep going. Okay. So it's not really a termination condition, it's a continuation condition. And then we don't do the c minus minus till after we're done. So the first time it's 4, we come back to this. Second time we hit it, then it becomes 3. Is 3 still good? Yeah, so keep going all the way till we get to 0. Then we go to -1. -1's not good, so we stop.
So
Hey,
just,
David,
Yes.
sorry. In a regular for loop, when you're counting up, those first two are flip-flopped, right? Because you would normally have C starting at 0, and then you have the length. But because it's counting backwards, you have to start with the length and then count down to 0.
100% correct. Yes.
Okay.
thank you for asking that, Christina.
So another way to do this. So let's do this a different way. Up here, using a regular one, I could say for int C equals 0. That's my initial condition. I'm gonna start with that 0 position. Okay. I want to go up. I'll keep doing it as long as C is less than C dot length. And then do a C++.
What if you just want to print some of the tokens and not all of them?
Oh, C doesn't have a length. It's not C length. I'm sorry, it's words. Yeah, words not length. And then I can just do the words sub C. So that's how we go through not using that weird for. Okay. So this is what we normally do. We start with 0, we go up 2, but not including the length. And then we do a C++ as we go through. What if I did a ++ C? Would that change anything? Did we talk about the difference between C++ and ++C?
We did.
We
but
did, but I don't remember now.
Me either.
I remember
Is it-
I never used the ++C.
You don't
Isn't
get-
it like something's added before and then something's added after?
Yes. Yeah, it's and in this case it doesn't matter. Either one should work.
Mm.
But
When doesn't it work?
well, it always works. It depends on what you want. So let's see. Let me think of an example.
Oh,
I had a student just ask
It
that.
would depend on
when
what
you
you
said for
started
this
with.
one it should, so I thought maybe there was a time it doesn't.
So let's say C is equal to 5. Okay. Then if I want to say see if this makes a difference. I don't care about you sentence. Yeah. Oh, that's really weird. Oh, no, that makes sense. Oh, because we're doing it twice. Right. See the difference here? When I did system out, print line C++, and C is 5, it printed out the 5, then it incremented to 6. Okay. In the second statement, it incremented it to 6 first. Sorry, it's already 6. Incremented to 7, printed out 7. Okay. You all look more confused than when we started.
Part of mine is being able to see it, but
Oh, I can make it a bit bigger, maybe.
oh, thank you.
So let's, okay, so we know that's going to be 5, right? Don't care, yeah, that's 5. But that's because it printed out the value of 5, and then it added 125. So it's 6 now. So if we just do a system dot out dot print line of just C now, that should be equal to 6. Okay. But if I would have done up here plus plus C, it's going to print 6 both times. Okay. Make more sense?
Yeah, it increments it before it prints it.
Yes. Yep. And up here it doesn't matter because it just moves on anyway. It doesn't do anything else. It's a pretty pedantic difference, but sometimes people ask about it. Okay. What other questions do you have?
David, I haven't been in the office hours where you've talked about the final exam.
Uh-huh.
Did you say what the 3 problems would be?
Well, it's all going to be, watch Thursday's video last Thursday, because I go through
Okay.
a kind of a mini review. So it's just on, what chapters are we on? 8? Is that where we start?
Yes.
Yeah, so it's going to be on creating objects. It's going to be creating objects with inheritance, and it's going to be on creating objects. What was 9 about? 9 was about something different. On 9's inheritance. 8's inheritance. 9's inherit. No, that's not. 8 is objects. 9's inheritance, and 10's polymorphism. Okay, so it's going to be basically creating things that do all of those different kinds of objects. Okay, and then from chapter 11, no matter what, and here's going to be the key on the exam, and I'll keep saying this, and people still won't pay attention. Most people will. You guys will, but some people won't. You want, even if I don't say check for exceptions, check for exceptions. That's the point of exceptions, right? Every time you ask the user for something, make sure they're giving you something that makes sense. Okay, so even on the exam, if I will not say I may say validate your input, but I'm not going to say use a try catch block. I'm not going to say that, right? Because that's one of the things we should have learned. If you're asking somebody for an integer, what if they don't type an integer? Remember, there's 2 issues. It could be the input mismatch, where if they type in letters, or it could be a number that doesn't work for some reason.
But we just have those 2 exceptions. So as long as we know how to do the input mismatch and then the arithmetic error, we should be fine.
Yes,
okay.
Basically, yeah. So I won't ask you a particular problem about chapter 11. It'll be integrated into whatever program we do. Okay.
Okay.
And then the string stuff's the same thing. Although I could give you a string specific question. Do something with the string functions that we talked about, with the split or whatever. So I mean that's a possibility. But
would that be kind of similar? Would that be really like kind of similar if we've done chapter 14, if we've done the homework?
Yes.
To something that we've done.
It should be similar, because I'm not going to test you on regular expressions. So I could test you on, I mean, any of those, compare to function, the equals function, you don't typically need concat unless you makes your code look better. It could be on the replace function. Any of those things that are the very first part of that chapter are all fair game. Okay. So if I had to guess right now, I'm guessing, I haven't made up the exam yet, but I'm guessing that there'll be the first, and again, they're going to be 3 1-hour exams, basically, with 1 question per. Okay. No option to do them all together. So the first one, you're probably going to create some classes. Okay. Remember, again, with the classes, I'm not going to tell you need accessors and mutators. You need to know that you need those. You know, I may say don't do this or whatever, or I may give you some stipulations of what the variables mean. But that first problem is going to be probably creating a class or 2. Okay. The second problem is most likely going to be to create some inherited classes and some polymorphic functions and some abstract stuff, probably based on those 2 classes you just created in problem 1. Probably going to connect those 2. Okay, so make sure you don't throw them away once you turn them in. And then the third one will probably be a string specific one, which could also be creating a class. You never know, but it's probably going to focus more on the string. Okay, that's what I'm thinking right now. That could change, but yeah, you should be able to create classes. You should be able to, when you create your classes, create at least 1 constructor with all the data. I could ask you to create other constructors. Remember, you can create as many constructors as you want, as long as they differ in their signature. The signature of a method is the number and type of parameters. So if you have an object with 4 integers, you could have 1 constructor that takes no integers and set all defaults. You can have one that takes 1 integer, which sets one of those values, one that takes 2, one that takes 3, one that takes 4. Okay. I probably won't ask you to do all those, but I could. Okay. And then unless it says otherwise, we're always going to put in the accessors, the get functions, and the mutators, the set functions. Okay. The set functions look just like your constructor for the most part. So if there's anything weird like the ones we've done with accounts with the balances, the balance has to be greater than or equal to 0. Whatever you do to test that in the constructor, you can just copy that part directly into your mutators. They're going to look the same. The same rules will apply there. Okay. And then, yeah, once you've done those, then be able to do the inheritance, you know, when you have a subclass, You should know about the difference between the other thing that I mentioned on Thursday. If I particularly ask you to be able to directly access superclass data from the subclass, then that should be clue in your mind, make that protected. Okay. If I say that you have to go through the normal methods, the normal accessors and mutators, that's a clue that you need to make it private. Okay, on the data from the subclass. Because remember, protected just means that anything derived from that can get to it. And that seems weird. I mean, if you have a vehicle class and a car class, and if you create an instance of the car class, it can't get to its own member data that's stored in vehicle. Okay, if it's private, it would have to be protected for that to work. Okay, so a lot of it is, I'm not going to lay it all out. I'm going to assume that you've done enough examples and you've done the homework, and assume it's a normal program. So don't do just what I say. Do what you should do to get the job done that I'm telling you to get done, if that makes sense. So that's kind of where I'm headed.
Hey, David, on the one with the polymorphism and the inheritance and everything, the
Yep.
one that we did, the homework problem that we did on the shapes where it
Yep.
was the 2D and 3D.
Yep.
Is that a good example for us to work through and understand?
Yes, it is. It's a little more complicated than I would ask on an exam. There's a lot of moving parts on that. So I would simplify that. Homework should be harder than the exams because you have plenty of time, you can ask questions. So, but that's the idea. The idea, again, polymorphism just states that, or just means that if you have a subclass and you have a method that takes the superclass, it will also take the subclass. Okay, so if I've got superclass X, subclass Y, if I make a method that takes an X, it'll take a Y too. Why will it take a Y? Because a Y is an X, right? It has that is a relationship. And everything that an X has, a Y has too, plus more. Okay, and that's the basic idea behind polymorphism. If you understand that, you'll be good.
But anything that's in the subclass is belongs to the subclass, so the superclass can't necessarily get to it, right?
It can't at all. It won't have
Okay.
it. Yeah.
Okay.
Yep. And then the other key thing is the idea of abstract. Remember, an abstract function or an abstract class is one that can't be instantiated. If you're doing employees and you have a bunch of different types of employees, then you may not have a generic employee. Somebody has to be hourly or salaried, for example. Okay. So to guarantee that nobody can make just an employee, but you want them to share characteristics, that's where you have an abstract superclass. Okay. If it's abstract and I say employee Bob's equal to new employee, it's going to say, no, you can't do that. It's abstract, right? Then you add the abstract methods. If you want to, you may have very different subclasses, but you want to make sure they all have the same method that looks the same. You put it as an abstract method in the superclass, and that's an obligation to all the subclasses. They have to do it. Okay. So that's the idea there.
So the abstract is just kind of like the overarching umbrella under which everything else falls if there was a particular way you wanted to set things up.
That's how we typically use it. But abstract just means that it can't be instantiated. That's all that it means.
Right.
But practically speaking, that's how we use it. We use it to organize things. So if you had 5 different kinds of vehicle types, you wouldn't want them to all have different ways of getting to the name or the whatever. The things that are in common, even employee, first name, last name, social security number, all those things, you want them to, you don't want to have to do it twice. So you make that abstract superclass. Okay.
And then you can just call that whenever you want it and put it in the form that you want it in.
Yes. And you would probably, a good abstract class or abstract method for that would be like get salary or get whatever. So if you have hourly and salary, they do it differently, but get pay could be an abstract function that you declare in the superclass that each of the subclasses would have to implement. Mm-hmm. And they can do it their own way with their own variables, but they don't have a choice. They have to implement it. Okay. And that's kind of like the interface example we did. It's an obligation to anything that uses that interface, but there will not be an interface on the exam. Okay.
That was going to be my next question.
Don't have to worry about that either. I'm trying to keep it simple. This is a skill class. The question on the final is, do you know how to program a little bit in Java? If you do, then you're good. That's
Okay. Or we just have a whole pile of examples right beside us.
As long as you can pull them together, that's good. That's what matters. Because you have to understand what they're doing. So, other questions? I have a question. Why do I have a cat toy when I don't have a cat? I don't know the answer to this question. I may have asked this before in class because it sits here right by my computer and I have no idea where it came.
Maybe your daughter or your wife did it just so you would have something to.
Because see, I have my sponge doodle, but I understand why I have a sponge doodle because I put the sponge doodle here.
Funny cat story for the day. We have like a 7-week-old kitten that we've had since he was like, we've never had a cat this small. He was like 3 weeks when we found him.
Teeny. Yeah.
And he had to go to the vet today to get some fluid. And so now his shoulder is full of fluid. And so he looks like the Incredible Hulk walking around.
Got him on steroids, huh?
And my youngest daughter came in and asked, she said, is his shoulder going to be like that forever? But he looks like the Incredible Hulk bulked up. And he's a tiny little thing. David, the only other question I have is on the project.
Yes.
As far as like, can we just do a regular like lesson plan as long as we include like a decent lesson plan? Does it have to have any particular like format? Because I know the format with the GoVA or whatever that is kind of simplistic.
Yeah, I would just have it in that. I'm not going to check it, to be honest. I'm not going to check it, but because if it's all there, I'm going to be fine. But since you're supposed to put stuff on there anyway, it just makes sense to me to use that Go Virginia format. It's just one less thing to worry about.
Okay.
So if you do that, you're good.
And then on the video link, it's just us kind of walking through how we would teach it to our kids, or maybe some examples or something.
It's if you were asked to explain to other teachers at your school how to do this lesson.
Okay. Okay.
Yep.
Because it's okay. On my lesson, I had thought about trying to do like an algorithm development. Like I was trying to think if I was really trying to teach this to the kids.
Right.
I have done some programming with Arduinos. And so one of the first things we do is like flow charting.
Yep.
To see like where do things go. And so I had thought about like having the like almost like cardboard pieces where they would kind of flow chart themselves. And then the code would be on the back side to see like, this is how the code like actually flows together.
Yes.
And then they could just like type it in.
Yep.
So I just was wondering like, how, is it okay to, I wasn't sure if that was enough information, you know what I mean?
Should be fine. Yeah, that should be fine.
Okay.
Are we, the 15-minute duration, you said we were, as if we were instructing another colleague, correct?
Yes.
Okay. So stick to that 15 minutes if it's over, or I don't know.
You don't want it 5 minutes. That's too short. If it's 3 hours, I'm not going to watch 3 hours.
Yeah, I wouldn't either. Okay.
So if it goes 20, I'm not going to stop at 15 and yell and run out of the room to say you fail. So, if you do it and you find there's a bunch of, you have to stop and start and you lose your way, just record it again. You don't want a 20-minute video with 10 minutes of you going, no, you don't want that. So just do it again, or you can edit it if you want.
Dr. Fraser.
But
funny.
I've had those from students, not from you guys. I would expect not, but I've had.
Hopefully we have a little practice. We've been doing this Zoom and recording on Screencastify for a year.
Teachers sometimes are not good students. They do things that if their students did, they would just kill their students. But when I have half a master's degree in history because I was bored, and that's just how my mind works. And there was a guy that was teaching history in the high school. And every time the professor would mention, is this going to be on the test? And I'm like, dude, would you let your students do that? No, I get mad at him. So why are you doing that? So I don't know, but yeah.
Teachers are a hard group of people. They
They are.
really are.
Well, yeah. And, I mean, before I taught college students, I taught college faculty the internet. That was my job. I was an IT guy, and I would teach them when the internet was relatively new and how to use it in the classroom. And yeah, faculty in general are hard because you know something or you wouldn't be teaching. You don't know what I'm teaching you, but it's hard to get the right level. And you guys are pretty easygoing, but some people probably in this class, if you try to explain it too easily, they get unhappy that you're talking down to them. Well, I know that. Don't talk to me that way. And if nobody is in here, you probably know people in this way. But on the other hand, if you don't explain it well enough, well, why are you just coming off like you know everything? Explain it better. So there's no, you would have to know what the person knew exactly to know how you weren't going to offend them. So you just give up and offend everybody and you don't care. But yeah, teachers can be tough. Well, and you're not used to being students. You're used to being in charge. So
Yeah.
it's a whole different world. So.
Well, and I've noticed in anything I've done with teachers won't shut up either.
Yeah.
They talk.
In a regular
Why
classroom.
are you guys talk?
Exactly. Yep. So, yep, that's true. But yeah, I've never seen you guys in person. You may not really exist. You could all be computer simulations for all I could know. I really don't think I've seen any of you in anything but a little screen. So when all this is done, you graduate, we should get together and like have dinner or something, because I'm curious as what you were really like, all you people, because and some people in this class, they've done well in every class. I've never seen them, never heard from them. They've never been on a Zoom. I've had no contact at all with them, except they turn their stuff in. So that seems weird. So I could pass them on the street and never, the people that are always here, I think I would probably know if I saw you. I'd be like, what, do I know you? Although, I mean, are you 5 feet tall? Are you 7 feet tall? I don't know. I mean, that would make a difference, when you're visually seeing people. So I don't know. It's weird. Don't we know people online, but
There's no way I can take a class and not have some sort of interaction. I just have too many questions because I'm a perfectionist.
Well, and it's an opportunity to meet somebody that may teach you something beyond what you're getting from the book. So, okay, I'm going to guess height. I want to do this. I think, Christina, you are 5'4". And Barbie, I think you are 5'6".
Yeah, you're right on for me.
Well, Christina, you shouldn't tell. You should wait. Wait till he takes the whole cohort out to eat.
So you're not gonna tell me if you're 5'6" or not? I bet you're 5'6".
No. Almost 5'5". You were close.
Okay. I'm close. Okay. But see, on the guys, it's harder because women are in a tighter range. You may know some of these people. Jude seems on the shorter side from his mannerisms. I don't know anybody that seems tall. Is there anybody tall?
Actually, I thought Jude was tall.
He may be, but he seems. I mean, I'm 6'2", so people seem short to me that may seem tall to you since you're 5'4". So
I would have thought you were tall, but not quite that tall.
yeah, I'm about 6'2". Yeah, very strange.
Everybody in my family's short.
Now my wife is like 5'1", so. But I had a great grandfather who lived to be 100 that was 6'6". It was freaky to see a 6'6", 100-year-old man, but that was him. and pictures when he was younger, people were not 6'6" back then, because he was born in the 1890s, I'm guessing. In like 1910, when he was like a 20-year-old, he was 6'6". Everybody else is like 5'4". So if there was an NBA back then, he would have played in it, but there wasn't such a thing.
So David, our exam opens next Wednesday.
Yes.
Next Wednesday through next Friday.
Yes.
Okay.
And you can
and then
anytime you want.
And we can turn our project in at any point.
It's due Wednesday, right? Isn't it due Wednesday? I think it's due Wednesday.
Like tomorrow or?
No, it's due next week.
Week.
Let me double check. Well, my Moodle's gone away.
I need to get on my project. I have it up here. I just haven't done it.
I know how that goes. I think I've got 2 or 3 textbooks I've written in my mind. I just haven't got my paper yet.
Well, it's got to mull around for a little while before it's like ready to come out.
It does. The gestation period, right? Okay. Final project. Due Wednesday at midnight. Wednesday, August 4th. 8
So is
days,
that a week,
4 hours.
a week from tomorrow?
Yes.
Okay.
Yep.
Can I ask a question?
Yep.
And I think I've asked this before, but really the only difference between a super class and a super class with abstract is just that word, right? Abstract.
Yes.
And that word abstract makes the objects not usable.
No, if the
Because-
if it's on the class definition, it means you can't make an instance of that object.
Okay, in that super class, and so the subclasses have to reword it to use it.
Well, you could make an instance of the subclass, but you can't make one of the superclass. Okay. If the abstract is part of a method, then it's going to be an obligation for all of the children to implement that method. Okay.
So one of the reasons you would want to do like an abstract method in a super class is to control that every other class had to have this particular method.
And
It's
it
more
looks
of
the same way. Yes. So
It's a-
again, if we go to the employee, I've got an employee as a superclass that's abstract that has the abstract method to get pay. Okay. Then I have a concrete class for hourly and a concrete class for salaried. So the salary has a salary, the hourly has the hours worked and the hourly rate, whatever. Okay. So rather than have to guess from some employee which one I'm going to, again, from a polymorphic relationship, I'm going to write a function called create paycheck that's going to take an employee, which means it takes either a salaried or an hourly. It's going to call that same get pay function. So by making it abstract in the employee, it means that, and it's going to take no parameters, but it's going to return a double. Okay. It means that both the hourly and the salaried both have to implement that function that takes no parameters and returns a double. So in my polymorphic function that takes a generic employee to do the payroll for the week or whatever, I can get that get pay and not have to worry which one it came from. And that's the whole idea. That's the point, okay, of all that. Okay. And again, it's the nature, and I run into this. I mean, everyone that teaches computer
I still
programming.
don't understand how that's different from just a regular super class and subclass. Because
If it were not abstract, okay, the two things. If we had an employee class that was not abstract, and it had the subclasses of hourly and salaried, I could create an hourly employee, I could create a salaried employee, I could create just a plain employee. And if you don't want a plain employee, then make it abstract. Okay. The other issue for an abstract class, I would make an abstract to pay. So whether it's hourly or salary, they both have the same function. If not, I mean, and again, it's the problem with teaching programming. In the real world as a programmer, you're probably not ever going to be creating the whole thing. You're creating a part. So you're creating either the hourly or the salary or just part of that. Okay. So you may come up with some function. You may call it get pay. Somebody else may call it get paycheck or whatever. So you have no way to enforce that they all have the same thing. So by putting it as an abstract function in your superclass, it means that every subclass has exactly the same function, even if it goes about it differently. And it just allows you to write things together. I mean, all the programs we do, pretty much, you can just do easier by hand, okay? Because I can't give you 6-month projects that take a team of 40. So when we're learning, we're doing things that we normally wouldn't do, right? We're taking very small programs almost to the point they don't make any sense, okay? So if you're writing both the hourly and the salaried, it's not a big advantage for you to make it abstract because you're doing both. You can make sure they're the same, okay? But it's about, in a bigger environment, the ability to force, because I mean, programmer Jeff may write the hourly and the salaried, and then 3 years later, they hire you to do programming, and you've got some other kind of employee. Okay, so because they have the abstract class, you know what you have to add, and you can't mess it up so the rest of the programs don't work, basically. It aids with the whole idea of polymorphism, okay? Again, if it's just you could remember that. It wouldn't matter on small programs, but on big programs with multiple people, that's the whole idea of abstract, just helps you out in those situations.
Okay, so
It's a control so that anything that's written underneath it has to be done a specific way.
Yep.
If you want to control the way the subclasses are made, you do that through an abstract class.
That's it. Yep.
but
You're
when
forcing
when you're inherited, when you have inheritance, don't you kind of have control with that too?
No, because this is not something they can directly inherit. If it's a function that's going to work the same, so let's say that you have for the employee a name, you have a get name method. If you put that in the superclass, well, then it'll just inherit it with the other classes. You don't have to worry about it because it's the same. It only comes into play when it's something different with each subclass, because every employee has pay, but how you determine it's different. You couldn't write one function in the superclass employee that would handle both hourly and salaried. Okay, so you make an abstract to make them deal with it. Okay, and again, it's an obligation to any subclass. Later on, they hire somebody else and they want to do a commission only employee. Okay, that they're still going to have to do that get pay because you've made it an abstract. You forced it on them. They don't have a choice. It won't run otherwise. Okay, and Java is made for big systems much more than Python is, although you can do Python for big systems. So a lot of the tools are too heavy-handed for one person doing work in an intro class. So we teach them now, but you're not going to see the value. But think about, instead of doing what you're doing, if you're doing something huge, then that abstract would really come in handy, really make your life a lot simpler. If you were writing a program for 5 employees, you wouldn't even make separate classes for hourly, and you would just put the salary in direct, right? You wouldn't mess with it. So we can never assign programs big enough to really show you the power of what we're teaching you. It's just how classes work. And you guys have the same issues. You can't give true real world examples to your students. They don't have the time or the resources. So you have to just give them something that's forced, if you're teaching math, have them show their work. When you're doing arithmetic, they don't really need to show their work, right? It's stupid simple. Why do you have them show their work? Because you want them to understand if the problem is more complicated, then they would need to show their work. So that's kind of the challenge. And I think that makes it harder to understand the concept of abstract, because we're not doing programs really big enough to need it. But I will tell you, a program that you wrote 2 months ago might as well have been written by somebody else, because you will not remember anything about it. So, I mean, most of my career, I worked as the only programmer, so I wouldn't make good comments. Oh, I did it. I'll know. No, I'd go back to make a fix, and I would have no idea what I'd done. So then I learned the hard way to write comments. So what else do you need to know? Got 9 minutes if you want to talk for 9 minutes.
Thank you. I will have to replay this video. If I had remembered when you told it to me the first time, I guess, yeah. Abstract is for more general. Inheritance, you want them to have exactly the same.
Kinda.
Okay.
Abstract is if the subclasses are different. If you can make one function that's always going to work, that's normal. Okay. But if you want to have it, I see what you're saying. More general troubled me, but I understand.
Okay.
In the way you said it, yeah, that's correct.
Thank you.
So David, just recap on the final exam, probably the inheritance polymorphism with the first 2 creating a class, some sort of something to that effect.
Yes.
And then probably a string.
Yes.
Question.
Class creation, inheritance polymorphism question, string question. It's my guess.
Okay. I think I'm good.
Okay.
So I'm gonna peace out.
Okay.
Thank you.
You got anything else, Barbie? Are you good?
I'm good until or Friday at 7.
It's Friday. It's Friday. Change it.
If I
Okay.
think of something else. Okay.
Okay, good. See you guys
Thank
later.
you.